Good day guys, your tutor engineer here. Today we'll be doing a grade 12 exam question on trigonometry. So let's get on with it. Given the equation cos of x minus 30 plus sine 2x is equal to 0, show that the equation can be written as tan x is equal to minus root 3 over 5. So let's have a look at this expression. So okay, for the sake of the space, I'm just going to be writing here. So we have cos of x minus 30 plus sine 2 sine x. Okay, so this cos of x minus 30 is cos x using our formulas multiplied by cos 30. Then you just change the sign here in between, then you'll find sine x and then sine 30. So this is 2 sine x as it is. So you'll realize that cos 30 and sine 30 form part of our special angles. So cos 30, you can just replace it by root 3 over 2. So let me just write it here in front to root 3 over 2. And then the cos x will come back plus sine 30 is 1 over 2 multiplied by sine x plus 2 sine x. Okay, 1 over 2 sine x and 2 sine x will give us 3 over 2 sine x. So this will be root 3 over 2 cos x plus 3 over 2 sine x is equal to 0. Okay, remember we need to get it to this format here. So from here I can divide both sides by cos x in order to get a tan x. So this will be root 3 over 2 on one side plus this is 3 over 2 times tan x is equal to 0. Now we are much closer to where we need to get to. So I'll take root 3 over 2 to the right hand side, it will be negative. And then multiplying both sides by 2 over 3 by 2 over 3. So over here I'll get root 3 divided by 6. Is that correct? Okay, I might have made a mistake here. You see 1 over 2 plus 2 sine x will give us root 5 over 2. So let me just correct that part here. So all of this will be 5 over 2 instead, including here 5 over 2. So that will be 5 over 2. 5 over 2. So 5 over 2. 5 over 2. So okay, now this is 2 over 5, this side here. Over 5, multiplying both sides by 2 over 5, that will give you minus root 3 over 5. So tan x is equal to minus root 3 over 5. So that's it, that's the proof. Now 6.2 says determine the solution of the equation in the interval minus 180 and 180. So this is the very same expression. We can rewrite it as tan x is equal to root 3 over minus root 3 over 5. So remember, tan x is equal to minus root 3 over 5. We can just calculate it as arctan. So if you put minus root 3 over 5 on the calculator, Okay, let's say root 3 over minus 5, then arctan. That will give me minus 19. So this is minus root 3 over 5. That means x is equal to minus 19,1 degrees. So, okay, if you plot this, remember the tan graph looks something like this, right? So it doesn't go through the 90 degrees, and then here you've got minus 90. It looks something like that. So for the interval of minus 180 to 180, this side will continue. So here you'll have minus 180, and then here you'll have 180. That's just about our interval. And then you have another graph here. I hope you can see it. Let me just use a different color there. Okay, so that you can clearly see. So this is the graph of tan. It looks something like that. So remember, minus root 3 over 5 is over here. Minus root 3 over 5. So if I draw a horizontal line across, okay, let me use a different color even for here. So if I draw a horizontal line across minus root 3 over 5, I'll find that the graph will be cutting that horizontal line at minus 19,1. That's where this minus 19,1. But there's other places like here where the graph will be cutting. So minus 180 minus 19,1 will give us 160,9. So that's another value of x here. So that's the answer. So definitely here we'll say the solution is x is equal to minus 19,1, or x is equal to 160,9. And then let's go to 6.3. In the diagram below, the graph of f of x is drawn for this interval. Okay, then the first question is determine the amplitude of the graph of f. So the amplitude is this. It's 2, the highest value. The highest peak on the graph is 2, so that's straightforward. And then the second question is draw the graph of f of x, g of x is equal to cos minus 30 in the interval minus 150 to 210 on the grid provided in the answer book. Clearly show all intercepts with axes and endpoints of the graph. Okay, so that should be straightforward. So this is actually the same, the normal cos graph shifted to the right by 30 degrees. So the normal cos graph, one would draw as starting from 1, it's going to go and cut at 90, and then it's going to have a minimum at 180. And then here, it's going to do the same, it's going to cut at minus 90, and then the minimum is going to be somewhere on the left hand side. So this is how the normal cos graph would look like. Then this one is still gonna go. This is the cos of x. So the graph that we are interested in is going to be the graph of cos shifted to the right by 30 units. So instead of having minus 90 here, we'll shift it here. So the graph will have a peak at minus 150. Sorry, it will have a minimum at minus 150 degrees. And then here it will shift again. The peak was at 0, now the peak is going to be at 30. And then here it's going to cut 30 degrees away. And then instead of it having a peak at 180, the minimum value at 180, the minimum value will move to 210. So this is the graph that we're really interested in. So I can just get rid of the original cost graph. Yeah, you don't need it now. So that's it. That's the graph here. And then finally, use the graph to determine the values of x in the interval -150 to 210, for which g of x is greater than f of x. So let's have a look. G of x is the cost graph. Here is g of x, and then here is f of x. The interface here, where we calculated, is 160,9, and here they intersected -19,1. So where g of x is greater than x would be this region here. So our answer should be -19,1 to less than 160,9. So this is the answer. And then now let's do the final question. The final question should be B, f prime of 1 over 2x is equal to 0. So this f prime means is a derivative. Where the derivative is 0, it's normally at the peak or at the minimum point. We're considering this interval, so don't forget about that. Let's look at f of x. Here is f of x, is the solid black line. So we'll replace f of x by 1 over 2x. F of 1 over 2x now will give us 2. Remember, since f of x is minus 2x, so that will be minus 2 sine. Where there is x, we'll replace it by half x. What's the implication of this? So the f of 1 over 2x means the graph was stretched, right? So remember, the sine graph is turning here at 90 degrees. Now it's going to be stretched to 10 here at 180. So it's going to be doing something like that. This will be our new graph. Okay, sorry, doesn't look good there. Let me just redraw it properly. So it's going to go and cross at 0, but it's actually going to turn here at 180. And then instead of it having a peak at -90, the peak will be somewhere here on the left hand side at -180. It doesn't form part of our range so far. So if you want f prime of 1 over 2x of the very same function, okay, it's not going to give us actually 1 over 2x. So if you want f of prime is equal to 0, we're going to look at where the graph is making a turning point. So the turning point is here. What is the value of x there? You got it, it's 180. So x is going to be 180.